This is Greg Troutline with Marine Technology TV. We're very pleased to be joined today by David Molyneux, the director of the Ocean Engineering Research Center at Memorial University, for a discussion of the assets of this world-class facility. So David, to start the discussion, can you give a brief career biography with an overview of responsibilities today at OERC?
Sure. I'll work backwards from the present. I'm currently director of the Ocean Engineering Research Center, which I took that position in 2016 after I joined the faculty at Memorial in 2015. I'm in the Department of Ocean and Naval Architectural Engineering, and before that, I was director of operations for a local engineering consulting company for 6 years. And then before that, I worked for the National Research Council, also in St. John's, predominantly doing research using their physical modeling laboratories, the big ice tank, the towing tank, the offshore basin, and so on. So, it was kind of a nice fit for me in the OERC.
As I said, we were discussing at the outset, I had a nice whirlwind visit to the OERC in late May. Can you give a brief overview of the top 3 or 4 assets of this facility, the crown jewels, if you will, that you believe define the capabilities of the facility?
Sure. It's not quite a straightforward answer because OERC itself doesn't own any of the assets. What the OERC was set up when Memorial started granting engineering degrees back in the late 1960s. And the idea was to make university research and resources available to industry. And so really the assets are the university's assets rather than OERC's. The oldest one is the tow tank with a wave maker, which has been used a lot for hydrodynamic studies into ships and offshore structures, and we've even put synthetic ice into it so that we can look at the changing hydrodynamics with ice on the water surface or iceberg-like shapes in close proximity to an offshore structure. The other really big assets that we have are more related to ship structures. We have some large structural testing equipment where we can test almost full-scale ship panels with ice, so that we can impact ice into these steel panels, which represent a ship, and they're very close to full scale. We had several projects using that type of equipment. There's a related piece which is instead of looking at crashing loads, looks at sliding loads, where if you like, a piece of glacial ice from an iceberg comes into contact with the side of the ship and is pushed into the side, because that actually changes the maximum load. And then I guess the fourth one would be our own little bridge simulator. You mentioned knowing Chris Hearn, where they have a really super deluxe ship bridge simulator. We have a smaller one that we use for developing education and training and research programs, which is now transferred to the National Research Council. But we still have partnerships with them so that we can still use it for our own research. One of the reasons for my move from industry to the academia late in life was that freedom to kind of investigate things in a bit more detail than you have in the commercial world. You've always got deadlines. You always feel, oh, there's more that we could do here, but everybody's on limited times and limited budgets. I mean, that's not that we don't have limits on the university budget, but we do have a lot more time to think about things.
Appreciate that insight again. So, when I was up before, I understand that you're building a new harsh environment research center that's set to open in 2025. A facility that I believe will house ABS's Harsh Environment Technology Center. Can you discuss the investment in this facility, why it was mandated, and what specifically it will offer?
Sure. It really is only a lab site. While the research is tied to the Harsh Environment Technology Center, it will only be the lab part of it. This has been on the go for several years now, and so we're really pleased to see it's actually scheduled to open next year. Um, it's really a sort of recognition of the excellence that Memorial and the local community have in harsh environments. And there'll be three labs within the facility. One is to study freezing spray impacts on ships and offshore structures where the way if you get the right atmospheric and ocean conditions, the water from the wave impact will freeze onto the structure. This is a concern for safe operation in that particular climate. We are permanently locating our sliding load equipment for measuring ice impacts on ships in that facility. And then the third part is for mechanical testing of uh, material properties of ice. Ice from a materials point of view is fascinating because it has a wide range of properties depending on temperature, salinity, loading rate. If we apply loads at a high speed compared to a low speed, the properties are different, and also the area of contact between the ice and the structure also have an impact on the load. And so we're putting together a lab to study that in a lot more detail. All these things have been done at Memorial for years, but with newer and bigger and more up-to-date equipment, we think that we can improve on our research output and the knowledge that we're creating.
You know, a lot of what I talk about St. John's, the Newfoundland and Labrador cluster, you talk about the people and the resources and the assets. So, looking, I guess, a little bit beyond those assets, can you talk a little bit about that collaborative nature of the people, of the expertise of the people that you work with, whether it's inside the university, whether it's in industry, whether it's in government, and how you see that all comes together to form basically what I consider to be one of the strongest clusters in the world.
Sure. Right, going right back to the formation of the Ocean Engineering Research Center in the 1960s, some of the projects, the very early projects, were on iceberg towing. Very quickly, it was about the time that the early exploration for oil production off the coast of Newfoundland was taking place, and people were concerned about Iceberg Alley and all the icebergs that were coming down the Labrador Current. And, it was a very simple question. Can you actually move these things out of the way if you've got something moored? And so that started some research into that. And, then other companies local organizations have developed that further. Seacor is a university offshoot with an extensive ice research history, particularly supporting the oil and gas industry. The National Research Council have their ocean engineering laboratories here, so they have a large ice tank. But these facilities are only as good as the people who can use them. So they have a long history, again, of ships' performance in ice. Within the university, many of my colleagues are working on projects on ship structures in ice. How resilient is a ship structure, particularly one that wasn't specifically built for ice. There's another conversation going on here with changing in the Arctic climate and global warming is making it more accessible to shipping. And so there's pressure to understand how a ship that wasn't initially reinforced for ice, how much capacity has that structure, so that if it should accidentally run into a piece of ice when you weren't expecting one, what damage is going to result? So this has been a big focus of some of our structures research lately. Um, we collaborate a lot with the National Research Council. We signed a collaboration agreement with them in 2018, which allows students and professors to work with NRC and use their extensive facilities for research projects. On the company side of things, American Bureau of Shipping have had a relationship with us since 2008, I think, so going back a long time. And so it's grown organically in the nearly 40 years I've been associated with Newfoundland, and as a potential gateway to the Arctic, and with our own laboratory right on a full-scale laboratory right on our doorstep, it's kind of a natural fit with the environment and the culture.
David, I truly appreciate your time. I really just have one more question. I know all of this research, big picture, is centered on the safety of ships, the safety of structures at sea, the safety of people at sea. Can you provide an overview or really a summation that discusses the work done at OERC and the correlation that you see between ultimately the safety of ships and lives at sea?
Thank you. Um, yeah, that's a very good question. Um, I guess there's always been a certain level of risk with going to sea to earn a living, whether it's fishing or transportation or oil and gas exploration and production. And so, in order to make that environment as safe as possible for the people doing it, there's been a long history of research into ship safety and offshore structures. Um, our particular focus lately has been on Arctic and related environments, because the Arctic's a very sensitive environment. It's a very remote environment. And it's an environment with a unique set of hazards. So, I talked earlier about climate change and more ships going into the Arctic. So, we do anticipate a growth in shipping in that region. And so making sure that whoever goes in there has the knowledge and the technical capacity to make sure they can come out safely is very important. And technology and knowledge, engineering knowledge, have a role to play in that. In the naval architecture world, classification societies have been the go-to organization for certifying our ships and making sure that they meet the best standards that are known to us. And so, as ships move into new environments and new areas, the classification societies in particular have to be ready for them and be able to answer their clients' questions of, can I go there safely and come back? So, it's been a really good fit for us with ABS and like-minded organizations, where we're looking at ships going into new areas for shipping, or more ships going, and ships, we're used to icebreakers being very strongly built and heavily built. But again, with climate change, do they need quite so much reinforcement, because all this is cost extra weight that could be cargo. And so, it's a very long-term horizon that we're working on. The things that we're doing now, we hope we'll see implementation perhaps in the next generation of the IMO Polar Code or the International Association of Classification Societies rules for shipbuilding and so on. So, we don't expect results immediately, but we do hope that we'll see them soon.